Let's talk about graphing sine inverse. If we look at the graph of y equals sine, we can see if you draw a horizontal line between pi and negative pi, okay, between pi and negative pi, horizontal line test fails because you touch your function in more than one location, which means that the sine function is not one-to-one and therefore does not have an inverse. Well, that means the overall function with no restrictions does not have an inverse. So what we have to do is we have to restrict our region for where the horizontal line test would pass. So what we're going to do is we are going to restrict our function between negative pi over 2 and pi over 2. So basically, if I restrict my function from negative pi over 2 to pi over 2, and only look at this section of my graph. Only look at this section of my graph. What happens? Well, what happens now is that if I draw a horizontal line in this section, touches it one time, which means, oh, this restricted sine function, yes, it is one-to-one, and yes, it does have an inverse. That's what we're going to do. The inverse of the restricted sine function is called the inverse sine function. Inverse sine function is denoted with a sign with a -1. We can also call it the arc sine. You are restricting between negative pi over 2 and pi over 2. So again, the sine inverse is y equals the inverse of sine at x. If you are to take your y equals sine inverse, rewrite, solve for x, if you take sine inverse and across the equal sign, it no longer becomes an inverse. So you say, oh, sine of y is x. And this is just a statement of, well, okay, if y is restricted between negative pi over 2 and pi over 2, then what's my x restriction? Well, your x restriction is the same as what it has been. That the sine values can only take on anything between -1 and 1. This is just spelling those restrictions out for you that we've talked about before. Okay, now let's talk a little bit more about that restricted function. The following points are on the restricted sign. Notice if we reverse the order of the points, we can see the points of sine inverse. So if I have the value of my angle being negative pi over 2, my sine function would be -1. This is for plain Jane sine. But what if I want to talk about sine inverse? Well, sine inverse, just switch swap your points, and now you have points of your inverse. Why does this work? Because the inverse function, if we go back and think about just regular equations, right? You always, to get your function, to get your inverse function, you always flip across the y equals x line, which means your x's now become your y's and your y's becomes your x's. And this again goes back to the idea of finding an inverse function graphically. Okay, so here we have our picture of our sine curve, blocked off the restricted from pi over 2 to negative pi over 2. Basically what we're going to do, here's that y equals x line. What we're going to do is we're basically going to jump over, okay? So that this point jumps over, this point jumps over, this point jumps over, this point jumps over, okay? So basically we're going to switch around our curve, switch it over, jump it over the y equals x line, which is what we have here. Again, remember your sine curve was that idea of shape. But if I'm jumping across that y equals x line, you can clearly see that when you jump across, you get the solid line here. What you see is what you get. It doesn't extend beyond these points. So this is it. This is the sine inverse function. The domain is anything between negative 1 and 1. The range is anything between negative pi over 2 and pi over 2. Okay? So example, how do I solve things for the sine inverse? Well, it says exact values of sine inverse can be found by thinking of sine inverse as the angle between your restriction. The angle between negative pi over 2 and pi over 2, whose sine is x. So for example, what if I want sine inverse of negative 1? Well, the way to ask yourself is, what is the angle where sine is negative 1? Answer, negative pi over 2. What if I wanted a sine inverse of 1? Well, the question is, what is the angle where sine is 1? Answer, pi over 2. So this is what we're going to do. How do I find exact values of sine inverse? 1. Write this statement. Theta equals sine inverse of your value. Step 2. Rewrite to basically take your inverse function, move it across the equal sign. When you move an inverse across the equal sign, it becomes plain Jane sine. Okay, no inverse. And then you say, okay, sine of my angle. But here is the only values that I can take on between negative pi over 2 and pi over 2. Use exact values of the sine to find that value of theta. Here's a question. Sine inverse of square root of 2 over 2. Step 1. Theta equals sine inverse square root of 2 over 2. Step 2. Move your sine inverse across the equal sign. Sine theta square root of 2 over 2. Question. This is the angle for which the sine is square root of 2 over 2 between negative pi over 2 and pi over 2. Okay? So you can write this statement, this between statement. Okay, like that. Now, let's go to our unit circle. Let's figure it out. Negative pi over 2, right? Negative pi over 2 to pi over 2. We're talking about this side of the unit circle. I want the sine function is the square root of 2 over 2, which means the y. Where is the y? Square root of 2 over 2. Well, that's not it. That's a negative, so that's not it. Nope, nope, nope. Oh, there it is. Any more? No. So the only value for where the sine function is square root of 2 over 2 between negative pi over 2 and pi over 2 is at pi over 4. So, step 3, solve using unit circle. Therefore, theta equals pi over 4. So that's talking about sine inverse. Let's go on and talk about cosine inverse. Cosine inverse. Again, if you look at this function, you can see that the horizontal line test is going to fail, which means that it's not 1-to-1, which means it does not have an inverse. Oh, well, what are we going to have to do? We're going to have to restrict again. This time we're going to restrict between 0 and pi. Why? Because if I restrict between 0 and pi, if I restrict between 0 and pi and just look at this function, just looking at here, horizontal line test passes, saying that yes, your restricted cosine function does have an inverse, and yes, it is 1-to-1. Alright, what are my values that I have to look at? Well, the y value, your domain here, again, can only be between 0 and y. Your range can be between -1 and 1. Please do not think about y as range and x as domain. Inputs, outputs. Okay, that's what you have to think about. This is input. This is output. The input, right? The input the output. Okay? Input is domain, output is range. Okay, now let's talk about our restricted picture here. Again, if I plot points of just x and cosine, I get these ordered pairs. If I want to plot my points of my inverse, simply flip-flop your ordered pairs. You'll get points on the inverse function. Okay, so what we're going to do now is we're going to break it down into how do we talk about getting that picture. Here is your cosine curve. What we want to do is talk about restricting it. Here's the restriction between 0 and pi. This picture clearly passes the horizontal line test. Now what you have to do is you have to take this picture and flip it over the y equals x line, which means that this portion will jump down, this portion will jump up. Well, here you have your arrows showing you exactly what you're going to have to do, where your pieces will go. So here we have our new function. This is the cosine inverse, or arc cosine, if you will. The domain, or possible x values, can be between, again, -1 and 1. And the range can be between 0 and pi. Go back and remember your rules for inverse functions. For inverse functions, your domain of your function is the same as your range of your inverse. Your range of your function is the same as the domain of your inverse. Well, isn't that true? Look here. The input of the original function was between 0 and pi, which now means that the output, or range, should be between 0 and pi for my inverse function. My range for my inverse is 0 to pi. My output, which is your range of your original function, is between -1 and 1, which now for your inverse means that your input should be between -1 and 1 for your arc cosine. My domain, my input for my cosine, is between -1 and 1. If you can remember these rules here, finding your domains and ranges become a little bit simpler. Let's look at an example of this. How do we work with this cosine inverse function? Find exact values of the cosine inverse function. Again, first, write this statement. Theta equals cosine inverse of your value. Rewrite. Move that cosine inverse function across the equal sign. When you move an inverse across the equal, it becomes plain Jane function. So I have just cosine theta x. Remember, your theta can only be between 0 and pi. So next you find values of the cosine between 0 and pi. That satisfy your equation. So let's look at an example here. Cosine inverse of -√3/2. Step 1, theta equals cosine inverse -√3/2. Step 2, a rewrite. Move that cosine inverse across the equal sign. Move it across, it becomes just cosine. Just cosine theta, -√3/2. Okay, this means the angle for which cosine is -√3/2 between 0 and pi. Between 0 and pi. Okay, so let's go to our unit circle. Between 0 and pi, along this ridge, between 0 and pi, where is the cosine function? Cosine's x. Where is the x? -√3/2. Well, that's the right number, but it's not the right sign, so that's not it. Nope, 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 nope. Yes, see if there's any more. Nope. So this is the only one at 5 pi over 6, where the x is -3/2. So that means solve using unit circle, and we found that the theta value we got was 5 pi over 6. So that means that cosine inverse of negative square root of 3 over 2 is equal to 5 pi over 6.